Hello my dear students, welcome to my physics class. Our today's topic is elastic properties of matter and intermolecular force. Intermolecular force. Intermolecular forces are the forces of attraction or repulsion which act between molecules and other types of neighboring particles, example atoms or ions. Intermolecular force is created due to two types of energy. A. The potential energy created due to interaction of surrounding molecules. B. Thermal energy of the molecules, which is actually kinetic energy of the molecules. Intermolecular force in solid. This is a solid body. Here the molecules of a solid body is shown. The intermolecular force is maximum. In case of solid, the intermolecular force is maximum. There is a very strong force. Intermolecular distance is minimum. In case of solid, that is intermolecular distance is minimum. Intermolecular distance means intermediate distance between two molecules. In case of solid, this distance is minimum. It has fixed shape and volume. Intermolecular force in liquids. These are the molecules of liquid. The intermediate distance between two molecules is small, but it is larger than the solid. Intermolecular force is relatively small. Intermolecular distance is small but larger than that of solid. In case of liquid, the intermolecular force is relatively small compared to the intermolecular force between two molecules of a solid, and intermolecular distance is larger than that of solid. Therefore, here intermolecular force is relatively small. Therefore, it has fixed volume but it has no fixed shape. The liquid takes the shape of container, therefore it has no fixed shape. Intermolecular force in gases. These are the gas molecules. Here the intermolecular distance is very large and therefore the intermolecular force is very less in gaseous molecule. Intermolecular force is very small compared to solid and liquid. Intermolecular distance is very large. It has no fixed shape and fixed volume. As the intermolecular distance is very large and intermolecular force is very less, therefore it has no fixed shape and it has no fixed volume. Elastic properties of matter and intermolecular force. We will say in graphically the relation between intermolecular force and intermolecular distance. We know what is intermolecular force and what is intermolecular distance. In this direction intermolecular distance and in this direction intermolecular force. This is the attractive force. From this graph we can see that with increasing intermolecular distance the force is more attractive. That is, with increasing intermolecular distance the attractive force will be more. And this is the repulsive force, that is with decreasing intermolecular distance the repulsive force is increased, that is with increasing intermolecular distance the repulsive force will be decreased. With increasing intermolecular distance the attractive force is more, but with decreasing intermolecular distance the repulsive force is more. That is, due to these two forces, this is the total force, this is intramolecular force. Here with decreasing intramolecular distance the repulsive force is created, and with increasing intermolecular distance the attractive force is created. Due to these two forces the total force, that is intramolecular force, and at this position, that is for this distance r0, when the intermolecular distance is r0, here net force, the total force is 0. That is, in this situation the attractive force and repulsive force are equal, therefore the net force is 0. When the intermolecular distance is greater than r0 the force is attractive, and when the intermolecular distance is less than r0 the force is repulsive. That is, at this situation the net force is 0 and this distance is equilibrium distance. Here r0 distance is the equilibrium distance. At this distance attractive force and repulsive forces are equal and net force is 0. When the distance is greater than this equilibrium distance the force will be, intermolecular force will be attractive, and if the intermolecular distance is less than r0 the intermolecular force will be repulsive. Therefore we can say at r is equal to r0 distance the molecules of the matter will remain in stable state, that is their potential energy will be minimum at this distance. At r is equal to r0, this is the equilibrium distance. At this distance the molecules will remain in stable state. Here this is the equilibrium distance between two molecules, that is r is equal to r0. We know this equilibrium distance depends on matter and temperature. For different matter the value of r0 is different, and at different temperature the value of r0 is different, and r0 will be changed if the temperature is changed. At this distance the molecules of the matter will remain in stable state. Now if an external force is applied and if the body is compressed, that is external force acts, due to this applied force the intermolecular distance is decreased, and as this distance is less than the equilibrium distance r0, therefore here a repulsive force will be created. This force is repulsive force and this is applied force F. Here the intermolecular distance is less than the equilibrium distance. If the intermolecular distance is less than the equilibrium distance, then the force is repulsive force. Here intermolecular force is repulsive force. Now if we remove this applied force, due to this repulsive force the molecule will regain its original position. Here applied force is removed. Due to this repulsive force the molecule will regain its original position. Now if the applied force is expanded the body, that is due to this applied force, that is external force, the body is expanded, that is intermolecular distance will be increased. Due to this increased intermolecular distance now the force will be attractive. Here attractive force is created between two molecules, and now if we remove this external force, due to this attractive force the molecule will regain its original position. Now the external applied force is removed and for this attractive force, the molecule will regain its original position. This is the main cause of elastic properties of a matter. If a body is expanded by an external force, there will be produced attractive force between molecules. Due to this attractive force, the body will regain its original shape and size. And if a body is compressed by an external force, the repulsive force will be produced between molecules, and due to this repulsive force, the body will regain its original shape and size. This is the main cause of elastic property.